Now, the last thing I want to cover in this chapter is talk about different kinds of food chains or industrial chains in terms of how energy and material flows through them. We have what is called a type 1 chain. This is also called a linear chain because it's like a straight line. It's a lot of raw materials go in and a lot of waste come out. It's a very wasteful kind of system. Then we have quasi-cyclical system. It's like a cycle where some materials go in and is processed, and a lot of the waste is used again, but does have some material that's ultimately simply discarded. The third kind of system is called cyclical. So this is a perfectly recycling entity, no waste at all. Whatever goes in is used. So they don't draw on more and more materials. What we see on the top here is a type 1 biological ecology. So this was the early part when Earth was just forming. There were unlimited resources because there were very few plants, animals, or anything. They were used, and then there was unlimited waste. It's a linear system. Then as Earth evolved and multiple life forms came about, it became a quasi-cyclical. So there is some energy and limited input. For example, you see the tree. From the tree you have acorn eaten by the squirrel eaten by the kite or eagle. And the waste product from birds may be fodder or food. In many parts of the world we have organic manure, right? Basically cow dung. And animal droppings are used as manure. The advantage is they are organic, they don't have any chemicals in them. We also use, this is a great example because cow dung is used in some developing countries to produce methane gas and thereby produce energy. So, but the point here is that the wastes are also somehow utilized. So it's almost cyclical, but there is a limited amount of waste. The third system is a completely cyclical system, right? So you're starting off, we could start here with the frog. The frog may feed on plants in the water, a dragonfly which pollinates plants, and then you have flowers here. I'm not sure I make full sense out of the cyclical process here, but the concept is that there's nothing coming out. You see, whatever goes in is used again and again and again. So it does not drain resources. So what is the moral behind all of this? Again, we're not studying, this is the technology class, we're not studying biological systems just for the sake of it. We want to see how we can be more efficient industrially. Well, the ideal anthropogenic use of materials. Anthropogenic is a buzzword. It just means anthro is human, genic, created by. So ideal anthropogenic use of materials and resources available for industrial processes should be similar to a cyclical system where once you put in some stuff, it's used again and again and again. We're not there today. We started off being a type 1 system, linear system, where that's what happened during Industrial Revolution and days ahead of that. We would just mine stuff, we would cut trees, we would do all kinds of things, and certainly we made goods and services available to people. But we also created lots of waste, and that kind of thing is not sustainable. In a few chapters from now, we'll see how we are reaching what is called a depletion time for certain resources like oil and gas. We'll completely run out of stuff like copper in about 50 years. So we can't do business as usual. So historically, human resource has mimicked type 1 ecology. Today, meaning not just today, but over the last 20 years, industrial ecology has emerged, which encourages recycling and reuse. So we want as step 1 to move from type 1 to type 2. there's still some waste, but the waste is much lower. But we don't want to stop with that. And from type 2, we want to move to type 3. So that is the goal of what we have set for industrial systems. So this chapter, to conclude, has demonstrated that the concepts and tools of biological ecology, called BE here, are important to our perspective of the industry. We can learn things, and a key thing is that they are inherently not wasteful, they recycle. So that's what we want to take. So last class gave you a fundamental framework. This class is also part of the framework where we compare biological and industrial ecological systems, and leave you with this guiding precept that as we design products, as we design processes, transportation systems, homes and factories, we want to keep this in mind. Are we using resources in a linear fashion? A lot of material goes in, a lot of waste come out, or are we trying to make it somewhat cyclical with the goal of ultimately becoming completely cyclical? So this concludes this chapter. Thank you.